That's really interesting. So, how is it that it's encrypted all of the time
Yeah.
in processing, but yet we could still do analytics on it, or we could train a machine learning model on it?
The idea is that you can compute in the cloud. Let's say you can do analytics or machine learning, but while keeping your data encrypted. There's the other approach, the more recent one, confidential computing, which is based on hardware enclaves. So we're talking about specialized hardware that is now available in the cloud, which is awesome. And the idea is that this hardware enclave is in the processor, in the basically chip, creates like a hardware box.
Raluca, welcome to the Super Data Science Podcast. Thank you for coming on the show. How are you doing today?
I'm doing great. Thank you for having me. Excited to be here.
Yeah, and so where are you calling in from today? We met in Boston at ODSC East, and I know that you spent a lot of your life in the Boston area, but
Yes, I
now I think you're
did.
on the West Coast.
Yes, I'm in the Bay Area right now, but I did my education at MIT in Boston, 4 degrees, so a long
Wow.
time.
And perfect GPAs all along the way. um,
Yes.
um, and so, congrats. At the time of recording, you recently wrapped up the Confidential Computing Conference, which I guess was that in San Francisco?
Yes, it was also in San Francisco. Absolutely, it was last week. Yeah, it was a very exciting conference. It's the very first in the confidential computing space, the very first in-person conference. It's, as you know, a very new area, disruptive technology. And so it was really amazing having this large, growing, fast growing community come together in person.
Yeah, my understanding is that it was oversubscribed, and so the one-day conference this year, you'll be expanding to a two-day conference in 2024.
Yes, absolutely. We were targeting for, since it's the very first event and it's in person, and we wanted to really make sure the attendees are extremely relevant to the conference. We were targeting up to, let's say, 150 to start with, and we got 250. And what was interesting was that almost everybody showed up. So there wasn't much of a, over registration not showing up. Almost
Mhm.
everybody picked their badges up. So
That's amazing. Congrats. So, in addition to running very popular conferences, you're mostly consumed, I imagine, by being president and co founder of Opaque Systems, which is a confidential computing platform for collaborative analytics and AI at scale. And we're going to dig into what will probably be the most interesting aspect of that for our listeners shortly, which is related to generative AI and LLMs and all of the kinds of privacy issues that are associated with that. But first, let's dig into what confidential computing is in general. So, tell us what a confidential computing platform is and how it works.
absolutely. So the idea is that you can compute in the cloud. Let's say you can do analytics or machine learning, but while keeping your data encrypted. So there's a lot to unpack there. So the idea is that your data, confidential data, will be protected by encryption, but at the same time, you can still do machine learning and data analytics on it. The cloud can see your data, so you can move your sensitive workloads in the cloud. Cloud employees cannot see it. Hackers breaking into the cloud, even if they get root access on the machine, they can't see your data because it's in encrypted form at all times during processing.
That's really interesting. So, how is it that it's encrypted all of the time in
Yeah.
processing, but yet we could still do analytics on it, or we could train a machine learning model on it?
Yeah, very good question. So I've done research in this space at UC Berkeley in my PhD at MIT, and now taking it to the company. And there's really two main approaches. One is using some advanced cryptographic mechanism that can actually compute on the data, and that one works in some settings, but it's still very slow for machine learning training and analytics. There's the other approach, the more recent one, confidential computing, which is based on hardware enclaves. So we're talking about specialized hardware that is now available in the cloud, which is awesome. And the idea is that this hardware enclave is in the processor, in the basically chip, creates like a hardware box. Now, in that box, the data actually gets decrypted, but only the metal can see the data. There's no human physically
Oh,
in that CPU box. Yeah. And as soon as it goes outside of the CPU box, basically outside of the die of the processor, there's an encryption key that's fused into the hardware that encrypts the data as soon as it comes, right before it comes out. So outside of this box and outside of the die, the data is encrypted on the bus in memory. So anywhere a human can access and look at it, it's in encrypted form.
this is a hardware solution, not a software solution.
Very good point. Yeah, yeah. So the security and the trust comes bootstrapped from the specialized hardware, but then you need the software stack on top of it, which is what Opaque provides to be able to work with this hardware. Because to work with this hardware requires a lot of expertise, like expertise on how do you manage the keys for this hardware. How do you? There's something called attestation where you can check that the hardware deployment was done correctly while being remote. There's things like ensuring end-to-end policies on who can see the result of, let's say, the model you trained or the prediction results. There's the scale out. How do you scale with this hardware enclave? So there's this big software stack that you need to run on top of this hardware in the cloud if you want it to be frictionless. So the whole idea of Opaque is to provide the software stack so that data scientists can use this without any friction. They don't have to think of confidential computing. They don't have to think of how hardware enclaves work. They can just use the software stack and run their usual pipelines unchanged. And then they don't have to think about all the complexity.
Very cool. I think I'm starting to understand it. So, the enclave part of it, is that like the hardware specifically, or it's kind of the whole system
Yes.
incorporating the software? Oh,
Yeah, very, very good question. So, yeah, the enclave is the hardware piece, it's the hardware enclave. It's specialized hardware provided by Intel, by AMD, ARM. So, most of the major hardware vendors right now have a hardware enclave technology, and it comes shipped with the modern server architectures. So, for example, Intel Skylake has it. Um, so if you look at AWS, if you look at GCP or at Azure, they have these hardware enclaves already available in the data centers, and you can just choose VMs that have that enabled. But then to handle all this complexity of how you deal, the expertise that you need, we have the software stack that Opaque provides, so that the user doesn't have to think, doesn't have to worry. Oh, am I using enclaves or not? How do I do with the keys? How do I push my data in that? How do I do scale out? They don't have to worry about any of this. They just run their usual system. So it is like a synergy of software and hardware, but the hardware enclaves itself just provides the hardware part.
I gotcha. And so I imagine something else that the software is critical for is ensuring that this encryption is very efficient. Like, I suspect
Yes.
that there's a risk here that if you have all of this encrypted data and you're training like a large language model, there's a huge amount of information in each round of training of stochastic gradient descent that is going to have to come out of encryption and then
Mhm.
have outputs be decrypted again very rapidly. So yeah, I'm guessing from your head nodding.
Absolutely. Yeah. Yeah, that's absolutely a very good question. And it used to be normally that encryption would add a significant overhead in performance. But the nice thing is that right now this encryption is in hardware. It's called ASNI instruction, which encrypts extremely fast. So it's almost never a bottleneck. Um, depends on your workload. It can add a few percentages in performance overhead. In other, really the main actually performance overhead comes from going in and out of the enclave, so you have to have a well designed system, and that's another thing that our software stack helps with. But the other exciting thing, because you mentioned generative AI and you mentioned the large amount of data, we now have GPU enclaves thanks to NVIDIA. So these hardware enclaves used to be just on the CPU, and a lot of the solutions they are for the CPU. But it's fresh off the press, NVIDIA is providing hardware enclaves in their Hopper architecture. And this is, I'm not advertising NVIDIA, but I am genuinely super excited about this. It's like awesome. So now we can actually run Gen AI at performance that is similar to not encrypted and insecure computation.
Nice. That is a very cool development. And yeah, as we know, GPUs are critical to being able to train. You
Absolutely.
can't be training LLMs, even the smallest LLMs, without GPUs, it takes forever. So that's a big change. That's awesome.
Yeah, it's very exciting.
And so, yeah, so it sounds like people can be using various cloud providers. All the major cloud providers provide these enclaves. Uh, Now NVIDIA has GPUs that allow for these enclaves. So then how does somebody, if somebody's listening to the show right now and they're like, oh, this is essential for me, I need to be using these enclaves. I need to be ensuring that all of my computing is happening confidentially. How does somebody do that? I'm guessing it's like using opaque systems. I don't know. You tell me, like, what's the flow? Like, what do I go to opaque systems or do I go to AWS or like, yeah, how do I get started?
Yeah, that's a very good point. I would say that especially for companies or users that don't have expertise in confidential computing, encrypted computation, the right answer is to go to opaque, and because it removes all this friction and all this expertise required. You don't have to think of how do you set up the enclaves, how do you move your compute in the enclaves. There's key management that has to happen. Then there's a testing the enclave environment. There's like a whole suite of things that require expertise. So the right thing is to go to opaque systems, and we can help deploy your system and your pipeline in enclave so you have no friction. Now, if somebody has a lot of expertise and they say, oh, I really want to build in my system from scratch, from the very beginning, using enclaves, then they could just start in a more raw manner directly on the clouds.
This episode of Super Data Science is brought to you by AWS Trainium and Inferentia, the ideal accelerators for generative AI. AWS Trainium and Inferentia chips are purpose-built by AWS to train and deploy large-scale models. Whether you are building with large language models or latent diffusion models, you no longer have to choose between optimizing performance or lowering costs. Learn more about how you can save up to 50% on training costs and up to 40% on inference costs with these high-performance accelerators. We have all the links for getting started right away in the show notes. Awesome. Now back to our show.
All right, gotcha. So people who already have a lot of experience, they could potentially be going directly to a cloud provider or doing it maybe on their own, in-house, their on-prem cloud infrastructure. But for people who don't have experience with confidential computing like me, and probably a lot of our listeners, the fastest route to confidential computing is using a platform like your Opaque Systems. Very cool. Something that you mentioned associated with Opaque Systems is that it's for collaborative analytics and AI. So what does that mean? How is that like encoded as part of this platform?
Yeah, that's a great question. I realize I'm saying that a lot, but you're asking good questions. So
Thanks.
um, so once you have this encrypted data processing and your data is secure and protected during computation, it's super natural to collaborate and to collaborate with sensitive data. So for example, there's so many scenarios where, let's say, banks want to collaborate to find money launderers, but without sharing data with each other because they're obviously in competition. Or healthcare organizations want to collaborate, for example, to find COVID patterns, or evaluate the spread of COVID, or find better diagnosis and treatment for cancer. But they cannot collaborate because, again, patient data is very confidential. So it's super easy once you have a confidential deployment like this in the cloud for everybody to upload their sensitive confidential data there, and you can run the joint analysis, maybe train a model jointly or do aggregate statistics without worrying that the other party is going to see your data, or really anybody, not the cloud, not hackers. And then you produce the final result, and then they can all enjoy, let's say, a better cancer prediction or treatment. So it's a very, very natural thing to do, to collaborate with confidential data once you have a safe place to do it. And the way Opaque enables it is it takes care of all the key management associated, because each one of these parties, let's say each bank or hospital, are going to have the data encrypted under different keys. So it's handling all that key management. Also, they're going to want different policies. For example, a bank might say, oh, I'm only willing to reveal the result if it's for example, if it's quality based on some testing data set. Only then I'm going to reveal the final model, or I'm only going to reveal certain information about my data, nothing else. So it helps ensure this end-to-end policies.
Oh, cool. So there's some level of discretion as to which data need to be private and other data that maybe can be shared. So it's not like everything that goes through a confidential computing system must always be encrypted all the time.
Yeah, exactly. So some things might not need to be encrypted, but you can also encrypt everything just to keep it easy. And we actually do recommend that. But I think where it's important to have this discretion, this policy is in the outcomes that you take outside of the enclave. So for example, let's say that you and I want to train an aggregate model together because we think that we're going to get the better model than training on our own data. But then I'm saying, hey, what if the model helps you more than it helps me? Maybe I'm not okay with that, right? So we can set policies saying, let's test this model on some testing data we each provide while staying encrypted before we reveal it to the parties, before we reveal it. And if it passes a certain accuracy that both are happy with, only then it's going to come out of the enclave and be visible.
Wow.
So you can set very, very advanced policies. And yeah.
That is super cool. That is not something that I like. That is well beyond the kind of questioning about this space that would have come to me organically. So thank you for bringing that up.
Sure.
Yeah, that's what kinds of scenarios are there? Like case studies where you could imagine that like practically that would happen? Like I guess maybe some different banks are collaborating on catching fraud or something, and I don't know. It's like one bank provides most of the data, and so I don't know. Help me, like make this example.
Yeah, absolutely. So I would say there's situations where, let's say, for example, we want to catch money launderers, right? And the model is, that indicates what are the suspicious accounts. Let's say maybe wants to say, oh, in this bank, there's something like 20,000 or 30,000 suspicious accounts, or maybe 100,000 suspicious accounts. And the bank says, wait a minute, that's too much. I don't want to reveal 100,000 of my customers' accounts because it's too much of my data. It sounds like something is not right with this model. I would like a model that's much more performant and much more accurate. So I only have to reveal maybe, 5,000 accounts that are really suspicious, something like this. So you can kind of control how much data comes out from the model. Other interesting cases that we're seeing is actually in ad tech, where we see a bunch of users is people, in ad tech, you can buy data sets that are proprietary. You can buy them and they tend to be expensive, right? And then they help you with your own business and maybe user recommendations. But sometimes you want to know, hey, is this data set going to be good for me before you buy it? Is it going to be useful or not before you buy it? Then the nice thing is that inside confidential computing, you can test it and see if it's efficient, what you want to do
Oh,
or
that's
not.
really cool. Yeah, that's a really great use case. That makes perfect sense. And again, something well out of what I would have thought about.
So it's interesting that you only need to pay for, you basically only need to pay for a query, not for the whole data set, which is not something that's really possible today, right? You can just really pay for a query and see if you're happy with the outcome of that query, how good this data set is for the specific query, and then you can maybe purchase the whole data set. But it's nice that the platform enforces the fact that you cannot get any more information about the data than you should.
Yep. Yep. Super cool use case. So, all right, let's start to get into this new realm that everyone is excited about: generative AI, large language models. What are the specific considerations that we need to have, other than, we already talked about this idea of efficient unencryption and re-encryption, I guess, and it sounds like that's something that is a solved problem in the encryption space. It doesn't sound, you mentioned specifically that isn't the bottleneck. So what are the kinds of limitations or challenges associated with confidential computing when we're training big AI models like the large language models that are everywhere now in generative AI?
Yeah, absolutely. And before I mention the challenges, I can mention a little bit the goals of what ideally would be amazing to have. Is we want the prediction, so the queries that users ask, we want the users to have privacy, right? These queries could be, for example, uploading proprietary code from an enterprise IP, like the case of Samsung, where an employee uploaded proprietary code to ChatGPT and basically revealed company secrets to ChatGPT in order to get some help to be more productive. But ideally, we'd like that to be protected. So with confidential computing, the nice thing is that you can put the model in an enclave. The LLM provider can put the LLM model in an enclave in the cloud, and then users can send encrypted queries to the enclave. And so the LLM provider cannot see those queries. There's a guarantee from the hardware, an enforcement from the hardware and the encryption. There's no way they can see what those queries are, yet they can still process the inference with high performance and respond. So now all these organizations and their employees can use ChatGPT or all the other LLMs without being concerned that the LLM provider sees proprietary company data. So that's one really big goal. Another goal is to maybe, if you're training from sensitive data sets and confidential data that the LLM provider shouldn't see, then you can actually do this training also in the enclaves. So what are the main challenges left? I would say that right now, the confidential computing community is really well established around the CPUs. The GPUs are much newer. So it's the Hopper architecture, which is much newer. They're getting right now available on the cloud. They're about to be available in preview. So it's super new in the cloud. So I'd say there's still this incorporating the GPU enclaves in the cloud and then just optimizing these pipelines and workflows. It's something that we still need to work and engineer. So on the Opaque side, we've been doing a lot of this engineering, even and thinking even outside of the cloud yet. But the nice thing is to have them on the cloud and to really get the best performance and that one can deliver. So I'd say it's still a little bit of unknown there because this GPU enclave technology is very new. On the CPU world, we know how things are very well, but we need GPUs here.
So in order to be able to get ahead of what consumers will need, does this mean that you at Opaque Systems potentially get access to like these new Hopper architectures and you get to like try them out and figure out how you're going to do confidential computing and have your pipelines and workflows in the cloud be efficient ahead of time before consumers have access to that kind of chip?
Absolutely. And so at Opaque Systems, a lot of our technology was built on top of our open source and research in our lab at UC Berkeley. And for example, this was even years before the NVIDIA enclaves became available. We had a partnership with Microsoft where we did research on how we do machine learning, neural networks, and analytics on a GPU architecture, GPU enclave architecture. It was all in simulation mode, but it still teaches you a lot about how to build a system on top of that. So we have a few years, I would say, advanced because of that research at UC Berkeley.
Can you dig into that a bit more? I find that really fascinating for some reason, so maybe our listeners will too. So I had never thought of this before. I guess I had kind of in the realm of quantum computing, for example. You'll have I know that there are tools you can go and use online where you can see what it would be like. You have these simulations of what it would be like to be using quantum computing to solve a particular problem. So you can kind of get used to the feel of that, even if it doesn't have the actual performance benefits of quantum computing. So maybe this is kind of similar to that, but that's it had never occurred to me that there would be other kinds of applications. So I'd love to hear more about it.
Absolutely, yeah. So for whoever is interested, also we have a paper called Visor. It's published at the top security conference, Using Security. So the idea is that first you need to know what is the API that the GPU enclave is going to expose. And then on top of that API, you can build your system. And in simulation mode, you can still get a pretty good sense of the performance. It's not going to run for real, but you're going to get a pretty good sense of maybe how many cycles it's going to take and some other metrics that you can then easily kind of do an estimation for the real hardware. Of course, there are some differences between the simulation architecture we use, Graviton, and the real NVIDIA enclaves, but it still prepares the thinking for the real hardware. So it still gives us an advance having had the chance to work in that simulated environment.
Nice. Okay, well, I won't take us off on that tangent for too long, Raluca, but that was fascinating on the simulations. Thank you. So back to LLMs. So at my company, Nebula, we we have generative AI models. We have our own proprietary LLMs. And so I can see how these kinds of solutions you're describing, where our clients can be using LLMs without us, without my company Nebula, being able to see any of their data. So they can feel confident in their employees sending data to us, which is important. So we hear sometimes when we are prototyping a new generative AI capability, we'll use something like an OpenAI API, GPT-4, to prototype it and make sure that it works well. But then in pitches, in client calls, prospective client calls, they say, you're going to have to be using your own LLMs. You won't be able to send our data off to that third-party API to OpenAI. And it's because of things like people being burned, like the Samsung example that you gave, that actually comes up in our client calls frequently. And it's interesting because while the OpenAI license is quite permissive for ChatGPT, actually for the API, they don't, unless you specifically opt in, they don't store your data for more than 30 days. And even just that 30 days that they do store it for is for the purposes of monitoring for abuse. But you can see how people are like, oh no, that's a company we need to avoid. However, so going one step further, we already know some people want to be avoiding sending things to OpenAI specifically, but there are surely lots of people out there who want to avoid sending even data to me, like to our own LLMs. There's a lot of our episodes recently on the show have focused on various open source architectures that you can download and then fine tune. And we've had tons of episodes about techniques like low rank adaptation, LoRa, these parameter efficient fine tuning techniques for being able to take pre-trained, really powerful open source LLMs, fine tune them to specific tasks. We've had, my data science team is regularly demoing things to me that I'm like, you built this? We have this? It blows my mind what's possible today. And probably regular listeners might even be tired of hearing me say it. But anyway, so this light bulb has gone off for me that particularly for our enterprise clients, I'm sure there are some out there that if we said, we're using Opaque Systems to take your data and we can't see it, it's just the bare metal enclaves that are going to have access. None of your proprietary information is going to be even possibly seen by us, by hackers. I can see the huge advantage to that in pitches. And I don't know if I've left you with anything to say.
You got it very, very right. You're very right. Absolutely. So I think that's really, a lot of the power of the LLMs will come when you use proprietary company data, not just the public web data. And exactly like you said, with opaque and confidential computing, you can put the foundational model inside LLMs and you can do your fine tuning in there on very confidential customer data. And then you can still keep the model in there,
right,
and answer prediction results that way.
Yeah, that's even a step further than what I just said, because I was just thinking about inference time. So I was just thinking, at inference time with a confidential computing system, I would be able to say to my clients, we won't get access to your data. But yes, I could be fine tuning on their data without seeing their data. That's wild.
Absolutely. You could be running any part of this in confidential computing. So you could protect users' queries by keeping them encrypted and doing the inference encrypted, but you can also do the fine-tuning in encrypted form. So you can have the whole pipeline encrypted, and then the customer really is assured that nothing about their data is revealed to you or OpenAI or anybody else. But again, there's flexibility. If you just want to run some part of it, for example, you say, hey, I really want to see that model I'm fine-tuning because by seeing it, I can do lots of other cool, interesting tricks and whatnot. You can, and then you can keep the inference only in encrypted form and protect the user queries, or you can have the model fine-tuning also be in encrypted form and say, I want to protect the data that it's fine-tuning using, but then I'm going to see the model, or maybe not see the model. You see, you have the perfect flexibility here of what you want to keep protected and what you want to see and who can see it.
Nice. Yeah, really exciting. You're opening my mind to lots of possibilities right now in real time. It's awesome.
We actually have, so we built a prototype like this in Opaque using the Vicuna open source
Yes.
model. We actually
Yes.
developed Vicuna in our lab, in the Sky Lab at UC Berkeley. It's a fine-tuned llama, basically, but it's we also, in our lab, we're running this chatbot arena where we have users compare and contrast what are the best open source models, and actually even compared to ChatGPT closed source. And so Vicuna, our open source model, is the best performing from the open source one. So that's quite exciting.
Deploying machine learning models into production doesn't need to require hours of engineering effort or complex homegrown solutions. In fact, data scientists may now not need engineering help at all. With ModelBit, you deploy ML models into production with one line of code. Simply call modelbit.deploy in your notebook, and ModelBit will deploy your model with all its dependencies to production in as little as 10 seconds. Models can then be called as a REST endpoint in your product, or from your warehouse as a SQL function. Very cool. Try it for free today at modelbit.com. That's modelbit.com.
Yeah, Vicuna is a recurring topic on the show. And for listeners that aren't aware of it, episode number 670 was dedicated to Llama. And then episode 672 was dedicated to Vicuna, Alpaca, GPT4All-J, Dolly 2.0, these various open source single GPU LLMs that are available out there. And I guess while I'm on it, then episode 674 was about this parameter efficient fine tuning with LoRa that we were also talking about a few minutes ago, that allows you to take these open source models and fine tune them. So Vicuna, for example, Berkeley, you took these llama weights that Meta didn't open source, but provided to researchers, including, I can imagine, Berkeley, in order to fine tune. And it's really mind blowing, like the amount of data required to fine tune so effectively to something like Vicuna that you're saying, gets these state of the art performance on benchmarks like you have in the arena that you mentioned. It's wild how like just a few hundred, or in most cases a few thousand examples. Like the flexibility and capability of the LLMs out of the box with this little bit of fine tuning on top. I think perplexity is like the best word for that, right? Where you get these emergent capabilities on such a small amount of fine tuning that is just stunning. Like typically we're seeing, my data science team on typically like the second or maybe the third iteration on trying to be able to do some task, absolutely nail it.
Yeah, I agree. It's really impressive. Also, I do want to mention that Vicuna is developed by my colleagues in the same lab. So they are the superstars here. I'm doing the security part.
When I said you, it was a very royal you. It was
thank
Berkeley.
you. I appreciate it.
Yeah, it's very good of you to make sure that I'm not implying.
My colleagues, Joey Gonzalez, Jon Stoica, and students are absolutely amazing doing the Vicuna, and I'm taking care of the security and confidentiality part. One thing that's very interesting there is that even when we have open source models, a lot of users are not going to want to develop their own infrastructure to run them and to do the inference. We know it's costly. We know it's expensive. Inference is actually more expensive than training because of the sheer volume of queries. So even in that case, they'll actually might want to put these open source models on some cloud, right? On some or with some provider, right? To provide a service. So yet again, we're back to the situation where some provider can see our queries, even though in principle we could run and host ourselves as open source. It just sometimes takes a lot of effort. That's another place where confidential computing can really come into place, extremely handy. And for example, if you put this open source model inside Opaque in the cloud, then you don't have to worry about creating the infrastructure for hosting the LLM. You don't have to worry about the fine-tuning on your sensitive data because it's all protected and can run in the cloud. So you don't have to set up this infrastructure on-prem. It's again about making this very easy to use and frictionless.
Nice. Yeah, all really great points. And it's interesting. We guess we don't say enough on air the point that you just made about how inference is typically more expensive. I mean, you hope that whatever platform you're building with these LLMs or whatever feature you're building is going to take off. But if it does take off, then it's like, you think about these potentially huge costs of training an LLM, especially if you're training from scratch. If you're taking an open source LLM and fine tuning it, the PEF can actually be extremely inexpensive. You could be talking about hundreds of dollars or thousands of dollars in compute to train the model, but then it's at the inference time that it's going to be crazy.
Absolutely. So then you have to have a platform, right, that supports this. And then let's say you're a company that's mid-size or smaller, and your business is not about setting up infrastructure for your LLM, right? That's not your focus. That's not what you want to spend time on. That's not what you want to hire for, or build infrastructure. And the idea is you just want to kind of delegate it for ease of use. So then again, you're going to delegate it to some other provider or to a cloud. So that's where, once again, you will need to think about the confidentiality of your queries, of the data you fine-tune using, the resulting fine-tune model, because the weights can also leak information. Many times neural networks remember too much,
Right.
and so forth.
Awesome. Well, so we've now talked a fair bit about open source LLMs and how people might not want to share information with the big providers like OpenAI. But what if you do? What if you want the best cutting edge API capabilities, the best generative AI capabilities? So you want to use Midjourney, you want to use the OpenAI GPT-4 API. If people are insisting on doing that, then are there steps that they can take to help safeguard their privacy anyway?
Absolutely. Very, very good question. And really, then the question is one of, what if a query contains PII information and you're sending a query with PII information to GPT-4? And I can completely understand why people might want to still use GPT-4. It's extremely good, right? So one of the solutions we're working on at Opaque, and we should have in the next quarter, it's not yet ready, is this idea of stripping off the answer, stripping from the query the PII information. So we're using, again, an LLM-like model to figure out what's the PII information, but it doesn't have to be as good as GPT-4 to answer the query, and replacing it with symbolic information so that GPT-4 can still reason in terms of that information, provide to us a helpful answer, and then we replug back in to that answer, replace the symbols with the information. And also at times we tag the query with relevant context.
All right. Talk me through an example. Give me an example so I can wrap my head around that.
Absolutely. So let's say that I have the medical report of a patient that contains SSN, name, date of birth. And I want to upload this whole document to GPT-4 that contains a lot of medical information. And then I just want to ask useful questions such as, when did this patient last go to the doctor? When is their upcoming appointment? What is their current pills that they have to take and whatnot? Basically, we need GPT-4 to synthesize this long medical record for us and be able to answer very direct and simple questions. So the idea then is that inside Opaque, inside Enclaves, we're going to ingest this medical report. Again, Opaque is not going to see it. And we're going to take out the PII. We're going to take usernames out. We're going to take social security numbers, date of births, very personal information out, but then replace that with some symbols. Then we're going to send.
So you could instruct the LLM. You could say, we're replacing sensitive information with like codes. The codes will look like this.
Absolutely.
You can just don't worry about the specific content in that code.
Absolutely. So let's say we call this patient X instead of, Alice. Alice is our usual victim in anything cryptography. Alice, Bob, and Malice. So let's say we replace Alice with patient X, and we send this new medical record with a lot of this PII replaced with code names, and we instruct the LLM about these code names, and then the LLM is going to answer, patient X last went to the doctor on this date. And we're going to, back in Opaque, we're going to change that X to be Alice, right? So the user sees an answer as if everything had gone directly to ChatGPT and to GPT-4, right? From the user's perspective and experience is the same as if they're talking to GPT-4, but the difference is that GPT-4 doesn't get to see any PII data, they only see symbols. And Opaque is going to handle all of that in enclaves using confidential computing. So Opaque itself doesn't see those PII. Nobody sees that PII.
That makes so much sense to me. It's interesting that when you first explained it, I thought it was going to be like really hard to wrap my head around, but it's crystal clear. That example is so obvious. Like I can see exactly how that would work, and I can imagine that it would work flawlessly all of the time. So just making sure that it's something that happens smoothly and easily is the kind of thing that Opaque can provide.
Absolutely. And it really comes with advantages for compliance. For example, HIPAA compliance is very clear about what you need to ensure. And by switching to symbols, you can ensure compliance with regulations like HIPAA.
Cool. All right. Well, that was a fascinating number of topics, Raluca, on generative AI and the privacy risks associated with using them, how we can overcome them. Let's switch gears a bit away from your commercial work at Opaque Systems to your academic work. So you're a professor at Berkeley, and there you co-founded and co-direct the Rise Lab as well as Skylab. So tell us about these research labs and the problems that you're tackling.
Absolutely. So I'll tell you a little bit of how, I'll start by saying how the Berkeley labs are structured, because I think it's a very unique model. So basically, every 5 to 6 years, some of us faculty group around what we think are the big problems to solve in computing systems. And that gets a lab and a lab name. And there's a lot of industry companies that are supporting us and collaborating with us, giving us feedback about what are the major problems they're seeing. And then we incorporate that in our research. So the Rise Lab had just come to an end 5 years ago. It was really focused a lot on cloud computing, security in the cloud and machine learning in the cloud, but in one cloud. So outcomes from that were prominent open sources like MC2 for us, which that's confidential computing and is the basis of Opaque. Also Ray, which you guys might have heard of and is the basis of Anyscale. So now we regrouped again and to create a new lab, the Skylab. And really the major problem we kept hearing a lot from industry and around is the fact that the world is becoming cross-cloud. So not just one cloud as we were in the Rise Lab, but cross-cloud, so going from the cloud to the sky. That's why it's called the Skylab. So there's companies have they don't want to be locked into any one cloud. And there's a lot of cross-cloud applications these days, lots of companies cross-cloud, but also because different clouds have different strengths. For example, Google has the TPUs, right? Or Azure has excellent confidential computing. So different parts of your pipeline might make sense across different clouds. So what we try to do in the Skylab is we're trying to enable that sky computation so that users and organizations can just run their pipelines in the sky without having to develop complex systems for which part goes on each cloud and trying to decide which is the most cost effective or the most performance effective way to optimize it. We do all of that. We basically schedule each component in wherever they should go. We optimize the cost, we optimize the performance, and we take care of the security cross cloud. So that's basically the big research thrust and the work we're doing right now in the Skylab at UC Berkeley. And obviously a big part of that are also, generative AI supporting that in a very efficient way in the cloud.
That is fascinating. So first of all, I didn't know about that Berkeley lab structure, but it doesn't surprise me because I've noticed when I am researching for guests at Berkeley, or just there's so much exciting research that even before I was a podcast host, I was frequently looking at things that were going on in Berkeley AI labs in particular. And it seemed to me obvious that there was a huge amount of collaboration. Like you see
Absolutely.
different co-directors, prominent AI people working together. I didn't know that they had these kinds of, I don't know if you would describe it as like a mission to like kind of accomplish over a
Yes,
certain number of years. Yeah.
yeah, it's a mission. We're all united in the lab for a mission. And we have, for example, the Skylab has professors in machine learning and systems and in security, because to accomplish a mission, you need to cover all of these aspects. Yeah, I think the lab structure is incredibly exciting. The way Berkeley managed to make it work, it has a huge track record. If you think about it, from our labs, Spark came out right in from the AMP lab. That was 2 labs ago. Or we have RISC-V or RAID or all these big open source projects. Again, the labs are about creating open source that has an impact and changes the world. Honestly, that was the kind of sexiest thing that attracted me to Berkeley when I finished my PhD and I had faculty offers, MIT, Stanford, Berkeley, and a bunch others. I just loved the lab model so very much. It felt like the right synergy of industry collaboration, research really coming together.
Yeah, fantastic. Seems like a great choice. I've never been to the campus, but it seems like a beautiful place, a very collegial environment.
You should come visit.
Nice. Yeah, I'm long overdue. Um, okay, so Skylab, it's focused on efficient, seamless compute pipelines across multiple clouds, taking them into the sky. I like that clear example of like maybe you'll want to use Azure for confidential computing, GCP for their TPUs. And so these different advantages of the different clouds, you can leverage all of those as an end user as you're developing your compute pipelines. So that makes a huge amount of sense to me.
As well
Um,
as smaller clouds. So the nice thing about it is that there's a lot of innovation in the smaller clouds, but they tend to be specialized at one thing, right? Or a very few things. They're not like Amazon, AWS, which is so general, has so many offerings. It intends to be kind of like a one-stop shop. And this really encourages also the innovation in the smaller clouds and just smaller deployments.
Cool. Yeah, I hadn't even thought of that. I don't. Yeah, it's so bad that the big players are so prominent that I spend an embarrassingly small amount of time thinking about the smaller players in the space.
Exactly.
Like in my mind, it's like, what's a small player? It's like the Alibaba cloud is small.
Yes, yes, yes.
um,
IBM is smaller as well. And
I guess so, yeah. But even those are huge.
yeah,
I'm sure
yeah,
there's for
yeah.
specialized use cases, there must be so many. There's probably hundreds or thousands of different cloud providers. You had specific, before we kind of transitioned over here, you said a
Yeah.
really fascinating specific topic. What was that?
I would say that some of the smaller clouds are also these mining pools, or like this big, this
Oh, yeah, all the spare
blockchain nodes
compute,
that used to, yeah, all this spare
the
compute
spare
is like
compute.
used to be specialized just for blockchain, but now there's thoughts of repurposing them for LLM, and that's also really exciting. Yeah, actually, speaking of small clouds, there's some also very interesting compute resources that are available in the blockchain world. As you know, there used to be this proof of work where you mine and expend a lot of compute to win some reward. But now a lot of the big blockchains, for example Ethereum, they moved to something called proof of stake, where you don't need to do that compute anymore. It's all based on something completely different, based on how much stake you have in the system and things like this. So now there's all that compute available, and there's mining pools, and so they're like little, you can think of them as little clouds, and there's all that compute available, and it's set up to work for some reward and for some goal. And then a very interesting research question we're looking at is, how can you repurpose those for training LLMs or for inference of LLMs, right? Those nodes are extremely good that you give them a task and they get the reward for what they're doing. And in fact, in the blockchain space, there's also this very interesting structure called slashing, where they put some money in themselves, and if you find that they're doing something incorrect, you basically get that money kind of like an insurance. So it's a really nice. Now, the challenge there that my students and I are thinking a lot about is, because it's not a major cloud provider running this computation, but it's lots of small people operating it. How can you trust, right? How can you trust that they're doing this training correctly, training a model correctly, for example? And because you have a huge computation, you give them different pieces, how can you trust that? Um, and yeah, for example, you could say, let's say multiple nodes could run the same computation, but then again, the costs will grow. Right now, there's actually some running estimations that if you have the compute run by these nodes, it's actually going to be cheaper than the clouds, because clouds charge premiums and GPUs are expensive in the cloud. You're actually going to get it much more efficient, much more cheaply with these nodes. But the problem with these nodes is that it's a bit the trust, right? They're so different operators from all kinds of different places. How do you know that they're doing the right thing? So that's a very big research challenge, one that we're thinking about in the Skylab.
That sounds like a really useful thing to be doing. If there's all of these cycles and devices out there not being used, they could be leveraged for, as we've already talked about earlier in this episode, the very intensive compute associated not just with training LLMs, but also at inference time. And so hopefully that can bring down the cost of running all these models. And it's thousands of startups have sprung up just in the last few months to take advantage of this and deployed across industries. But in order for that to disseminate across all of the world and across all industries, as lots of people anticipate over the coming years, the coming decade, we're going to need to be able to compute cheaply. So this sounds like a really useful aim, a really useful mission of Skylab.
Thank you.
Let's talk about your feelings on closed source versus open source more generally. Some of the providers of these big LLMs are increasingly closed source. So one of the most cutting digs for OpenAI is to call them for OpenAI is to call them closed AI. They were set up with this mission of open sourcing AGI, and now with GPT-4, their technical paper on it doesn't provide any details about the model, whereas at least the GPT-3 paper a couple of years ago did. So, what are these kinds of trade-offs? What's your perspective on it? Are there some things that tech companies should be keeping closed source to remain competitive, or does this stifle innovation? Are there security implications? I imagine there's a lot of ways and a lot of thoughts, a lot of ways that you could go on this, a lot of thoughts that you have.
Absolutely. Very, very good question. It's something that we've been debating a lot in our own lab. We recently had a retreat with companies, and we spent the whole panel just arguing about open source versus closed source. And my colleagues are pretty divided, I would say. I think I'm somewhere in the middle in the sense that I think that proprietary LLM models are still going to be extremely, extremely good, just because it takes a lot of money and resources to do, that all the data collection, to have access to data, to train an LLM process. So I think, why isn't Google, for example, search open source, right? And so I think there's still going to be, I think the proprietary ones are still going to have some advantage, but I also think that open source LLMs are going to become, especially foundational models, are going to become very, very good. Also, there's some thought on whether the government is going to step in and want to help with open sourcing quality LLM models, just because there's more control then, right? And there's just more transparency about what's going on. It just comes back to trust and confidence, because we all know that these LLMs can have a significant impact on society if they're not, conducted with care. The other aspect that I think it's interesting is that I think there's going to be not necessarily one LLM provider to cover them all. I think there's so many domains of knowledge and of expertise. For example, I know there could be a really good one in that tech, could be one in a certain kind of insurance, right? So I think there's going to be companies coming up that will be specialized at a domain, and they'll fine-tune the LLM, the foundational LLM, that's probably an open source LLM, and fine-tune it for that domain of expertise so good. And they'll have access to confidential data for that domain, and that will make their LLMs extremely good. And I think there's a place for proprietary LLMs there, and like very domain specific. And I think they'll be better than a general LLM provider will be at that specific task. They won't cover all the other tasks, but they'll be better at that specific tasks. So I think there will be some sort of decentralization of this LLM providers based on tasks and based on domain.
Yeah, I think I'm 100% in the same boat as you, Raluca. I see the same thing happening. There's too many groups out there, like at Berkeley, working on Vicuña and open sourcing that. There are too many clever people all over the world coming up with ways of being able to, especially as you say, for these domain-specific use cases, having smaller models, with 3 billion or 7 billion parameters can run on a single GPU that can be quantized and run on a CPU very cheaply, very quickly, that tackle these specific tasks, and provided that the creator has maybe some proprietary data that they have from their niche that they've collected from lots of users, they can create a model that's better than the big proprietary ones from Anthropic, OpenAI, whatever.
Yeah. And I mean, speaking of open source from versus proprietary from the perspective of security and privacy, there is a clear advantage of open source there, right? You can take an open source model and run it in your on-prem, right? And you can send queries to that model that are proprietary and no problem, right? It runs in on-prem. It's not like you're sending those queries to a remote LLM provider that can see now organization data, code from your organization. So there's a clear advantage of open source models over proprietary ones when it comes to privacy and confidentiality. There is, though, I think, another challenge when it comes to privacy and confidentiality, and this is something hard to address even when you have an open source model that runs on-prem. So you train, let's say this open source model is fine-tuned over your organization data, right? But then what if Alice asks a question like, what's the salary of the CEO? So now if this LLM model is trained over the whole organization data, now the thing is that even in an organization, there's pockets of knowledge, right? There's access control, there's walls of information flow. And how can we teach an LLM model to respect those walls? And that's really challenging. I mean, you can tell them, hey, don't provide financial information to Alice or not, but you probably can't exhaust all those possibilities, and probably somehow indirect queries could reveal. So that's, I would say, a very challenging question with open source or proprietary. So how do they keep track of these information walls?
Yeah, a year ago, a really trendy term for describing solutions to this problem prior to LLMs kicking off, prior to ChatGPT's release, there was a lot of talk about this idea of a data mesh. And so we had Zhamak Dehghani in episode number 609 of this show. She coined the term data mesh and wrote the O'Reilly book on the topic. And so, yeah, it was a fascinating technical deep dive into these kinds of problems around when you have an organization, the HR people, they need to know this CEO salary. They need to be able to pay the CEO's paycheck every month. But of course, that isn't necessarily going to be information that everyone in the company should have. And so it's interesting, these even so with that data mesh concept, there was this idea of having data distributed across different departments, and you have rules as to who can get access to what. But with LLMs, as you're alluding to, this is really hard because there's no longer these strict boundaries. It's just model weights distributed across the whole model.
Exactly. They combine, and exactly the weights are affected by really all the information. And we know, in security and cryptography that sometimes you can reveal information indirectly. For example, if I know that Alice leaves for work every day at 8 a.m. and whatnot, then I can infer the fact that, okay, if she's living at home, then she's going for work, right? Or something like this. So it's indirect knowledge that you can infer, even without asking a question directly. So how do you kind of prevent that?
Yeah, so at this point, I guess that's just a question. There's no
Exactly. It's a research question. There's some attempts. I've seen NVIDIA guardrails have some interesting proposal. There's some attempts at teaching the LLM to, respect some rules, but it's not going to be precise. There's going to be ways to get around that.
Yeah, interesting problem. I'm sure we'll see lots of attempts to solve that coming out over the years, so that we don't have to have a department level LLM across the organization, and the engineering complexities of having all those running. It'd be nice to be able to have one big LLM that thoughtfully respects privacy in a way that we can trust. So that'll be
Yeah,
really interesting.
that would be
Cool.
very nice.
Really great points across the board on open source there, Raluca. Um, Quickly, other than Opaque Systems, you have another startup, PreVail.
Yeah.
And so this is a cybersecurity company
Yes.
born out of research that you did back when you were at MIT before you were at
Mhm.
Berkeley. And so tell us a bit more about that. I know it's to do with end-to-end encryption.
Absolutely, yeah, absolutely. So PreVail is a company now. I think we can assume it. We can consider it graduated from the startup status. Um, it's right now almost 8 years old. It's in Boston, and we have 800 enterprise customers. So it's doing very well. We provide basically encryption for files, and think of Box but with end-to-end encryption. Not even Box can see what your data is. Think of email there and a chat all packaged in. And really the main attraction is the fact that we're compliant with some extremely stringent compliance. For example, from the defense sector, CMMC, ITAR, we make all of this compliance so much easier. We are integrated with enterprise modules of various sorts. For example, I don't know if do you use Proton Mail or Signal or Telegram.
I don't personally, but I'm aware of all of them, and I'm aware that there's certainly people who are like, you've got to be using them, and you can't be using anything
Yes,
else.
exactly. So those are for users and for chat. Think of PreVail as the same thing for enterprises, and not just chat, but files sharing as well, like Box, Dropbox, and email. And think of a stringent compliance. So yeah, PreVail is doing really well. We're very excited. We're voted by PC Magazine as the #1 encryption for email encryption for enterprises. So that's very exciting.
Cool. So serial entrepreneur now, with two successful cybersecurity startups, well, companies under your
Second one
belt.
is a startup. Second,
Yeah.
Opaque is I would say 2 years and a half in, so it's probably still has the startup title.
Um, so what motivated you to be doing entrepreneurship while also maintaining a significant academic career?
Absolutely, I think that for me as a professor, I just want to improve. I want to impact the world and improve the world through better technology. And I think writing papers and solving important big problems that you then publish in papers, I think is the first step. But it's only the first step, because in order for you to actually change the world, you have to go and do it for real. I think that papers that sit on a shelf rarely get picked up by companies. They do get picked up sometimes, but it's much more rarely. What I believe strongly in is doing it also. So not just saying how, but actually going and doing it and making it frictionless to use and really demonstrating its full capabilities. So I really enjoy this whole tech transfer. And I think Berkeley, a lot of my colleagues at Berkeley are quite like-minded, and Berkeley is just such an amazing university that actually encourages us and supports us in doing this tech transfer and having both an industry hat and an academic hat. It's actually funny, there's this joke going around that how in computer science programs the top are #1 are on the same position, Berkeley, MIT, and Stanford, but people say that MIT is too far from Silicon Valley, Stanford is too close, and Berkeley is just right. So I think that's true. I think that right distance from Silicon Valley really enables us to make our research real and to inform our research from what companies really need and problems they face, and then also get that adoption through tech transfer.
Yeah, a colleague of yours, whom I know you know very well, Peter Abil,
Yes.
who was in episode number 503 of this show, an interesting thing that he said about the difference between academia versus industry. So he's in robotics. He hosts the Robot Brains podcast, and you've been a guest on that show. So this is like a robotic specific thing, but I suspect, and you can maybe elucidate on this a little bit more, that it's probably similar in your space as well. that in academia, Peter was concerned with being able to show off completely new capabilities. Like I think the example that he gave in the episode was something like the robot hand that was doing a Rubik's cube. It's like that's a really cool thing to be able to show academically. You're clearly demonstrating, you're really pushing the boat out in what robots can do.
Yeah,
But
yeah.
that's not an industry application.
Right.
For industry, you're not interested in being able to get a video once of a Rubik's Cube being solved. You're interested in extremely low error rates, for example, that you need. The robots don't necessarily need to be doing the craziest things you can imagine, but what they do, they need to have like 99.99999% accuracy on doing it. So there's these different challenges with getting an academic paper published and making a big splash with that paper relative to building a successful product in the industry.
Absolutely. Yes, I completely agree with that point. It's, you develop the research, develop technology, and then you say, oh, let me do tech transfer. And you think, okay, the very first part, obviously, of doing tech transfer is building a very robust product, absolutely robust, right? That it's not going to fail for the user. It's super tight when it comes to security. That's first and foremost. But it's actually not enough. Then you realize there's this whole other big, slice of the pie, which is about, okay, but why would the user use this as a priority? Like, why would the business buy this product as a priority over all the other things they need to do? Why is this a huge pain point? So, and one thing that I realized in security is that if you tell them, hey, you're going to have so much stronger security, you're going to be so much less exposed to hackers, and it's just so much stronger than us, they're going to say, that's really wonderful. And it's something I would like to have, but it's not my number one priority right now. I need to figure out how to be compliant, or I have to figure out how do I, even acquire this data set that I need. So that's another part of, if you want to do this technology for real and you want it to be adopted, it's not enough to do research. It's not even enough to build an amazingly good system. You also have to demonstrate to people how it beats their other priorities. For example, one thing I found that it helps with security is not so much convincing them about stronger security because they believe it, but it's not a priority. It's the fact that, hey, you can actually be more easily compliant. Like, you have to be compliant. It's going to be cheaper to be compliant. It's going to be faster to be compliant because this technology is just better at security. So it's easier to be compliant with it. Or, hey, you want to get this other data set that they cannot share with you because it's confidential. That's what confidential computing and Opaque enables you to. Now you can acquire data set. Now you can collaborate. So it's about enabling this functionality. It's not so much about just strengthening security.
Yeah, really great case study there, and shows, the impact that you can make, the value that you can drive as an entrepreneur beyond just having your academic career. It's something that, like, candidly, looking back, there's parts of me that I'm like, wow, I wish I did stay in academia after my PhD. Like, I can see so many, when there's people like you or Peter, the amazing things that you're doing at Berkeley. I'm like, to have that kind of community, to be able to go in and tackle these problems together instead of like largely on my own as an entrepreneur. The appeal, is huge. So I'm
It's a lot
super
of fun.
jealous.
It's a lot of fun. It's a lot of fun. Probably the one thing you won't be jealous of is the lack of sleep.
Yeah.
In making all of this happen. But it's so much fun. In fact, it's just so stimulating and exciting to have both the academic and the industry part. That what's the point of sleep?
Very good. Yeah. In addition to making an impact as an entrepreneur, you also advocate strongly. You make a big impact promoting diversity and equity in the tech industry through initiatives such as the DARE program, DARE, DARE. Do you want to tell us more about why this is important to you?
Absolutely, yeah. So DARE stands for Diversifying Access to Research and Engineering. And the idea was that I was trying to debug and understand why is it that in research there aren't enough minorities in research in computer science, and I was really trying to get to the bottom of it. So I was talking to a bunch of minority groups at Berkeley, and they were telling me, "Oh, it's so daunting. to get started on research with the professor. There's, for example, in my security class that I teach every year, there's 700 students, right? And I'm only one, right? I have TAs, but I'm one professor. So if they want to do research with a professor, they have to kind of compete with 700 students. So what was shocking was that some minority students were incredibly strong. They had exceptional performance in my class, in other classes, and they weren't even attempting to contact the professor because they thought, oh, there's no way I could get this. And so it was a confidence issue, and they would just, go for an industry internship where they could have also that exposure to research and all that teaches you. So one thing that we did is when we created the idea is that the professors contact the students and the grad students contact the students. So it eliminates this barrier. And how do we do that? Well, we have we have all the users' data, the students' data on classes they took. They upload their CV to a system. They don't have to be shy about talking to professors because they're just uploading their information to our system. And we have a clever matching algorithm that matches. We know from each professor what kind of student they're looking for, what profile, and we match them with a professor, and then we show them to this professor some extremely strong students. And the professor and their grad students are many times are like, wow, I really want to work with this and this and this. And they send an email to the student, hey, do you want to chat? Do you want to contact? And it removes that barrier for the student to approach the professors and approach the research, and the professors come to them. And we've seen a lot of success since the program started. We had more than 100 students do research, and at least roughly half of them are minorities, either low socioeconomic background or ethnic minorities or gender minorities. And so that really helped. And it's nice because it equalizes. It's no longer based on who's intimidated or not. It's really based on, are you fit for this research, and also based on professors choosing to have a diverse and healthy group, research group.
Fantastic. Yeah. And it's great that you were able to identify like this specific cause, like a contributing cause to this lack of diversity issue, and resolve it. So like, yeah, it's another example of not just like doing the research on it, but also making that real world impact.
Thank you. And an exciting, actually a fun story here, one that I'm very happy about is, so my one of my PhD students actually, Wenting was my first PhD student. She is now a professor at Carnegie Mellon of computer science, computer security, and she's also right now implementing the same program there. So my students are taking the program that they're programming and kind of implementing it at a few other universities. That's very exciting.
It's so good. There's, so many reasons why this is so essential. Obviously, everybody who merits it should be getting a look and should be getting their chance and be able to have the same kinds of, amazing life experiences as everyone else. But then also selfishly, in terms of like a world perspective, with all of these open source tools that are available to us, all of these inexpensive or free educational resources that are out there, there's never been a better time to be alive for somebody to be able to, all you need is an internet connection, and you can be thinking of product ideas, you can be creating companies, you can be making a real big social impact. But that impact is only maximized if everyone feels like they can do it.
Absolutely.
And if there's only a subset of the world's population that feels like they could do it, then obviously the total social impact is smaller.
Absolutely.
So yeah, cool that it's propagating, and it'll probably keep going and keep going.
It's going to be interesting to think how to expand this to areas outside of computer science where research happens differently. And I personally don't really have a clue of what, makes a lot of sense there. This was very, custom designed for engineering and for computer science, really.
Yeah, but some of these smart people are going to figure it out for sure. Well, thank you, Raluca, for taking so much time with us. You've been so generous with your time, especially given the complete lack of sleep that you have with your entrepreneurialism and your cutting edge academic work. Before I let you go, do you have a book recommendation for us?
I guess you really see what a nerd I am in answering this question. I really think that if you want to keep track of the biggest innovations in security and privacy for AI, analytics, machine learning in general, I would really say that conference proceedings of IEEE Symposium of Security and Privacy is what I recommend, because the advantage of that, it's a book that keeps giving. Every year you have new research, cutting edge research in the space that you can keep track of. Yeah, so very nerdy answer, but that's what I think is.
As it's in the 3 years or so that I've been host of this show, I think it's the first time we've had conference proceedings recommended as the book, but I love it. It's really well suited to you. And it makes a lot of sense. You're right. Annually, you get a whole new book, nicely updated for you. That's awesome.
Because I also think that people's views, any person you take, their views are pretty skewed of this world, and there's a lot they're missing. They have some pretty good insight, but there's also a lot that they're missing, even like the smartest people in the world. And whereas a conference proceeding is kind of the voice of many, so I tend to believe it's more of a reliable source of information. And yeah, I know I'm very nerdy answer, but yeah.
All right, and Raluca, very last thing. Obviously, you are a brilliant communicator. Your answers to all of my questions today were so crisp, and they were condensed perfectly, but also had great, clear examples that made them easy to understand. So I'm sure there's a lot of listeners that would love to follow your thoughts after this episode. How can they best do that?
Thank you. I would say that probably following me on Twitter. My name, Raluca Ada Popa, is probably the easiest. I tend to announce some of the bigger initiatives or work there, both academia and industry. I also have a website with my publications. I think the Twitter covers both research and industry endeavors.
All right. Thank you so much, Raluca. This has been an awesome episode, and maybe in a couple of years we can catch up again and see how things are coming along.
Sounds great. Thank you so much.
Well, that was a slam dunk. In today's episode, Raluca filled us in on how hardware enclaves on CPUs, and now recently GPUs, allow data to be used for analytics, inference, or model training without anyone, including the model owner, being able to see the unencrypted data. She talked about how you can even call a commercial generative AI provider's API, such as those provided by OpenAI, or train an open source LLM without, again, anyone accessing data you'd like to ensure is kept private. She talked about how her Skylab is enabling efficient, seamless compute pipelines across multiple clouds, such as Azure for confidential computing, GCP for their TPUs, and smaller cloud providers for their specialized capabilities. She talked about how open source LLMs, especially domain-specific ones, will likely be competitive with commercial LLMs on specific tasks, and how open source AI development may lead to better security. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Raluca's social media profiles, as well as my own social media profiles at superdatascience.com/701. That's superdatascience.com/701. All right, and I always assumed that, like me, people mostly listen to podcasts that they're subscribed to, but I recently discovered that's statistically not the case. So if you're not already subscribed to this show, please do, to be sure not to miss any episodes of this twice-weekly program. Of course, I also greatly appreciate it if you rate the show on your favorite podcasting app or give the video a thumbs up on the Super Data Science YouTube channel. And if you have friends or colleagues that would love the show, let them know. All right, thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another awesome episode for us today. For enabling that super team to create this free podcast for you, we are, of course, deeply grateful to our sponsors. Please consider supporting the show by checking out our sponsors' links, which you can find in the show notes. And finally, thanks of course to you for listening. I'm so grateful to have you tuning in, and I hope I can continue to make episodes you love for years and years to come. Well, until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.